He is currently working as a technical leader with Cisco Talos. Vanja?
Thank you. Hi, everybody. If I knew that they will read my description that I sent about like a short biography, I would probably put that a lot more. But like the thing I would put likely is that I was something that I mentioned when you need to know some like a curious fact about a person, you know, team building exercise, that kind of thing. I used to be an opera singer as well. When I was 12, actually, I was part of a Croatian National Theatre children's choir, but when my voice mutated, then that's where my opera career ended. And so I had to become like a malware researcher in the end. Not that great, but yay. I was hoping for so much more. So what are we going to cover today? We'll just go into like a brief introduction of what Autoit language is, and then like general idea of how can we obfuscate the Autoit code, or how the malware writers are trying to do it. Then we'll talk about classic like a process injection methods which are required by scripting malware to actually launch a PE payload in the end. We'll go through a Zyklon case study, which is one of the case studies just to show you like an example in the wild, and a couple of them. And then I will mention a few tools that if you are into analyzing like malware and trying to analyze Autoit malware, that would or could hopefully help you with the actual analysis process. So what is Autoit? I don't know how many people know about Autoit. Yeah, not too many, but like I'm sure that people who analyze malware are reasonably familiar with it. So this is a language that's developed in 1999 by Jonathan Bennett from Birmingham in the UK. I think at the time they were developing so to make a better VBS than the VBS was, and largely for automating graphical user interfaces. And some people are using it even today for, let's say, installing installers, like automated installing of some of these like installers. It has an extensive library of user-defined functions, and it has a very strong community, forum-based community that contributes with the user-defined functions and with bug reports and so on. There's even a real ransomware written in Autoit. This is an open source project just to show that Autoit is like a fully functional language. This is not very super great, but you could see that the price is equivalent of $200 in Bitcoin, roughly equivalent what every other ransomware would use. So what are the strengths of Autoit? I kind of highlighted in orange reddish thing, which the functions are used by malware writers. Apart from simulating the keystrokes, you can manipulate Windows processes. There's a full network stack. You can directly call Windows DLLs, which will prove to be crucial with process injection. And it also has a very well documented help file which will help you to develop your own script. So just an example of how the script look like. It's a very much basic language. So it also has some of the weaknesses from the sort of malware writing point of view. It's an interpreted language. So when you have a script code, you can obviously read the code and you can modify it the way it suits you. So for example, if there's anything like an encrypted a file embedded in the script, then you could easily change the script so it just simply dumps the file to the disk, and then you can analyze it as a PE file. There's no powerful data structure, so there's no like a list, or there's no like associative, there are no hashes or things like that like in other scripting languages. So in that sense it's very basic, and we'll see that that prove to be a bit of a problem with analyzing in the end. And then there are no native functions for like standard ASCII type encoding that are used in the wild, like base 64. This is just an example that I was supposed to be mentioning before, and obviously I've written this one. You could see how the global you have the include at the beginning to include some of the constants that are used by some of the functions, and then like you define variable scopes. These are the usual names of the variables that I use in almost every single of my scripts. I don't know why, I always use Chemi and Pero. So, and this is just like an example that writes something on the screen using console write, and gets all the hard drives and then prints them out to find. So it's very, very simple. So how the malware writers are trying to obfuscate? It's a classical, like any scripting language like JavaScript or VB-script, PowerShell is being obfuscated by choosing like a random variable names, inserting junk code at the beginning or anywhere within the code. The whole idea of obfuscating, of course, is twofold. One is to make your analysis more difficult, so when you read the code, it's more difficult to understand. And the second is when you have anti-malware detection that uses, let's say, string type patterns that you will be able to, let's say, make at the beginning not detected malware, which would then easily be detected in the end. So those are the kind of classical way they're trying to use it, and an example is this, like you have like a 2 lines of code which just launch and wait for the WinZip to be active. That's taken from the Autoit help file that shows how to automate user interfaces, and then you send Alt-S keystroke to continue the setup. So if you use an obfuscator and you add the same code through the obfuscator, and I think this is from the ploc guy, then you get something like this, which seems to be very difficult to read at the beginning, except at the end you get those two last lines that are very much the same as the beginning. So those can be so much more obfuscated as well, so you won't be able to recognize that there are those lines included in the code at all. So that's the idea of the obfuscation. The malware writers are trying to use, there's this sort of idea in some of the kind of script kiddies forum of the FUD malware, and I always think it's fear, uncertainty, and doubt. And I was always thinking what kind of fear, uncertainty, and doubt malware is, but it turns out that it's a fully undetectable malware. And of course, there's no such thing as fully undetectable malware, but let's these guys think about that there is. Sorry that this screenshot is not great. It seems that the projector is not working well, but this is like a user interface of an obfuscator called Data Scrambler that seems to be very popular and is being used by the example which will be shown later. So this is one of the pattern of the infection from left to right. We have at the beginning generally what you get is an email that has an attachment, and that attachment may be or may not be an exe file. More commonly these days it's some kind of document file that contains an exploit. And then the next stage is the first, let's say, first stage of the Autoit, which the malware writers are using either self-extractable RAR files or self-extractable CAB files, which can be configured so that another file is launched automatically when you double-click and when you open it. Generally, what they do is they create a randomly named standard Autoit interpreter. They drop that, and they drop several other files onto the disk. One of the files will be an obfuscated script, which is then used as a parameter for the Autoit interpreter. And then we also have generally the encrypted PE payload, which is then, by using the input from the obfuscated script, is decrypted by the shellcode stage that's going to be run within the process space of the Autoit interpreter. And then when that's done, when the PE file is decrypted in memory, then another process will be launched, and typically the executable from that process will be hollowed, so it would be taken out of the process space, and the malware executable would be included into the process space. So I don't know why they use this convoluted system, but I think the most likely it is that the actual payload only exists in memory. Well, exists on the disk as well, but in the format of an encrypted payload, so it's not very easy to detect. The other way they're trying to use, same as, let's say, Python to executable, where you can, from Python script, you can create an executable file. They create an executable file from the Autoit script, where typically has two components. One is the script itself, and the other one that can also be embedded within the file and use a simple script to drop it is this embedded, again, encrypted payload. And then, again, we have the process injection in a more or similar way. So those are the two most common methods that have been seen in the wild. This is just to show the same idea, is that the payload only exists as a PE file in memory rather than on the disk, and this is this image is like just to show that high level of entropy on the file. So the file is encrypted. You really don't see any kind of structure that you can use to detect, except if you find, let's say, a file with a randomly named file with a high entropy on the disk, then you may be able to detect it in a way. But generally, you don't know what it is. So I don't know if it's a good idea to detect that kind of thing. What are the functions that are used in Autoit malware for the PE process injection? Well, like I said, there's no great C or C++ like structure that you can create in memory, but there are calls that start with DLL. DLL struct create allows you to create a C++ like structure. So, for example, you can you know how the process environment block looks like, or how the PE file looks like, and then you just define that in a DLL struct create call, and then from then on you can address parts of members of the structure to modify parts of it. With using the structure set and get data, you change the data of the structure, and you get the pointer of the structure using the call. So at the end, the DLL call is the one that's most important, and basically starts running the process injection process, or the shellcode that does the actual decryption. So those are the kind of classic Autoit calls that are used by the malware. And then we also have the Windows 32 APIs. I won't go through them. I think they're all well known for people who are analyzing. One of the things that perhaps worth mentioning is this call Windows process, which is, as far as I've seen, used by Autoit malware to launch this first stage of shellcode, which basically decrypts the PE payload from the disk to the memory. And basically, as one of the parameters, it takes a callback. So what they do is they create a buffer in memory, they poke the buffer with the shellcode, and then they call Windows proc with the parameter of a callback, and that's where the whole process starts running. So we'll go into one of the real cases that I found a couple of months ago, and this is what actually launched or kickstarted the whole more in-depth look into Autoit malware, and then I realized there are actually quite a few of those flying around. Like any kind of malware, it starts with typically an email, and this is an email which I found in the telemetry that's used by the products. Like Cisco has an email gateway product and spam traps, and that's when I saw that kind of interesting, because it's slightly different. It has two attachments. One is the letter of introduction.doc, and the other one purchaseorders.zip. So why would you have two attachments? I have no idea, but that was kind of interesting. It looks like a reasonably legitimate email, but of course it's not. So the first stage, if we open the document, is a CV 2013-3906, an exploit in Word document that basically that's an exploit in parsing TIFF image files, whereby you can modify the image file so that a function pointer is overwritten, and these active X bin files are used to spray the memory with shellcode, and then you're hoping that when you override the function pointer, it will jump into your shellcode, and you could see the typical kind of shellcode 41 statement, the, what is it, add AX something. And so this is, at the end, you could see the actual URL, so it's very easy to recognize that this is a non-encrypted part of shellcode. This is a standard download and execute type of shellcode. The only thing that I found kind of more interested with this, that it also tries to avoid some of the behavioral type detection. So if you try to detect behavior in user mode, then typically you will have function hooks starting with a call or a long jump or a breakpoint instruction. Some of the, I guess, anti-malware products using behavioral type detection will hook those Windows APIs. So what these guys are doing is if they encounter any of these presumable hooks, they will jump right in front. They will kind of jump over the five bytes, and they will call the function, hoping that they won't be able to be detected by anti-malware products. So the second stage is Autoit. It basically, when that file is downloaded, the final from the command and control server, when you extract it, then you see many files on the disk, and one of them is a 110 megabyte long file. So when you start reading through it, you think, oh, there's no way you can read it. And the only thing here you could see is it could be a Unicode file, and there are a lot of like Unicode spaces, and there are some kind of garbage characters and whatnot. And when I started kind of browsing and looking for strings, eventually somewhere like down the bottom of the file, you could see some of the, potentially obfuscated code, and you could see execute binary to string, blah, blah, blah. So, okay, it's an Autoit file, and with the super binary data structure language, whatever, also known as three regular expressions here. I was able to quickly recover basically the source code, remove all the noise, and come up with something that looks like this. Again, is not very easy to read. And then the next stage, which I'll talk about, I use a tool that would allow me to do a little bit more, and now I can see all these constants, and I can see which function calls are called. You can see DLL call, get tick count. So one of the things that guys are doing is that they're trying to see whether you're running in some kind of execution environment where if you take much longer, they won't be then executing the malware to the end. The third stage of the payload was just like a PE file that gets decrypted and then injected into the process memory of some of the processes. Well, it was an obfuscated.NET assembly file. Again, there's a whole different topic of how you deobfuscate .NET files, but I really don't like to analyze them. They can be pretty nasty with some of the obfuscation techniques. The only thing that I found is these guys modified the actual Zyklon botnet, and so if you launch it as a file from a command prompt, you will quickly get this message box saying this is not meant to be used this way. It only has to be encrypted. It only has to be injected in memory, so you need to do some checking there. Well, I'll skip this because this is not really visible, but it just shows the whole line from the email to several layers and then eventually to a command and control server. So I will just briefly go through some of the useful analysis tools. Exit to Autoit does the reverse of Autoit to exit. So executable Autoit files have either a resource section or they have an overlay that starts with like a magic string, and you can always recover the source code, which is great if you're analyzing that kind of thing. Exit2Auth or the Autoit, those are the two tools. Both of them are freely available, or if you search, good enough. Regular expression and scripting, we saw that before. And then the tool which I really liked, and I found it recently, is Ault parser. And the parser is really written in it's written in Autoit again. Somebody was trying to write an Autoit parser in Autoit, which is kind of an interesting exercise. And a sort of debugger. The developers of Autoit are very careful not to allow debugging, knowing that it's very, very easy to reverse engineer, I guess, this. And so the only provision for debugging in the actual Autoit is like console write or something like print lines and so on. But there's another guy who created the debugger, and it's actually pretty good. So the parser has two functions. That one is to parse the file. Well, two interesting functions. There are many, many functions, of course. The parsers are pretty complex pieces of code. And the other one that's very useful for analysis is called deparse. So the first one creates an abstract syntax tree, basically from some kind of code. It creates an in-memory representation of an expression. So here we have a variable, and on the right-hand side we have plus operator, multiplication, and division, right? So it basically allows you to then traverse the tree and then go back from this sort of representation in memory back to the source code. And this is used by the bad guys to obfuscate the code, but it could also be used by us good guys to deobfuscate the code. So what you can do is this is like the weird problem with analysis is there's no good structures for creating the abstract syntax tree. So an example that this parse program creates is basically a two-dimensional array that by some kind of convention has the right and left branches of the operation. But we are not that much interested in that. We are really interested in taking this and converting it back to the readable source code. So for example, here we have the deparse function, and the deparse function, what I try to do is now some of these weird function calls like binary to string, which I wouldn't be able to read, I define them as something that when they detected in the code, I can create my own, let's say, emulation or my own handler for this, and then I deobfuscate the script or the string and return it back to the source code. And then another function that was in one of the examples. And so this is like a big switch case statement in the Autoit code that basically the most interesting part for me is when you find a function call, what to do with the function call. So we also have here if the function call name is within my own functions that I defined. In that case, I call the function that I defined as a handler. One of the examples here is this function that basically does some kind of decryption, deobfuscation of a character, and it returns the character back as a standard string. So from here, you could see an obfuscated string that has a global variables that are pretty much unreadable from here, except you can only see the function calls. And when you parse it first and then deparse it, you are returned back with the same code, except now you have this sort of word deobfuscated string instead of the function call. So you really have more information about what's inside the Autoit script. And then, one very simple regular expression is like if you search for quotation, space and remove them all, then you get it and you put together everything, and now it's much more readable in a way. So I found Autoit Ault parser very useful. The other useful tool is the debugging, and as I mentioned, there's not really official kind of provision for debugging within Autoit, but somebody create a graphical debugger that basically from your own script or from the script it creates an instrumented Autoit code, then uses communication to communicate with the debugger, which communicates with the Autoit interpreter. So you kind of get breakpoints, you kind of get inspection of the variables, and it is pretty useful. So from the same script that I had at the beginning, as an example, the instrumented script is basically this. So every time you script one line, a new error is set, which basically then allow you to inspect variables and things like that. So it's not really a debugging provision, but it's better than not having anything. So how do we try to find this Autoit type of malware? Let's say if you're using VirusTotal, which is of course the repository that most of the people are using, you can create your Yara rules and look for the RC data type resource in the PE file with the name script, and then check whether the Autoit signature is there as a part of the resource, or you have an overlay with the Autoit signature and you'll be able to find them. For the RAR and self-extractable cab files, then that's a bit more difficult. Then I usually use the import hash, file size, and the detection name by anti-malware tools, and most of them are detecting with some kind of Troj, Autoit, something, and that's where you find these interesting things. And of course, you can also try to use some of the behavioral rules from the VirusTotal when certain temporary file names are used. I think it's used one of the temporary file names, aut something.temp. So you could see from there as well a bit. Some of the more common malware families that are using are Lokibot, and I encounter a dark comment, which is the remote access Trojan. Zyklon is another bot which is used for like botnets and denial of service attacks. But there are quite a few of them, and if you look for them, you will definitely find them. So now how to protect against? Well, just as we recommend for PowerShell or VBScript or JavaScript, if you don't really use them, then disable them. Try to prevent from running. If you really don't need an Autoit interpreter, you simply just can say, well, if anything tries to run Autoit interpreter, I will block it. And if you really need to run Autoit interpreter, if you use it within your own environments, then you could at least detect that the Autoit interpreter uses a random name. And then you can again block it. Same thing with the Autoit to exe files. So I hope I didn't kind of I don't know make you too much bored about this topic, but I found it reasonably interesting. For me, it was a useful couple of weeks when I looked at this, and I needed a good topic for the conference. So I hope I succeeded. The only thing before me and I think the next presentation and the lunch is maybe we have a break. I don't know, but I wanted to invite you. The only marketing slide I have is to invite you to listen to our Beers with Talos podcast, which members of Talos are discussing like everyday security issues almost on a weekly basis, and it's been very successful, and most of the people say it's very entertaining. Unfortunately, the free beer is just upstairs, but not not within the podcast. So with that, I think we have maybe a couple of minutes for questions before we break for something, a break or the next presentation. Yep.
You mentioned sandbox detection.
Mm-hmm.
In your experience, besides runtime execution speed, what are the most common techniques malware uses to detect sandbox?
In malware in general, or?
Maybe in this case and in general.
Well, there are so many different ways for detecting sandboxes, but also there are different ways of trying to prevent against this sort of detection. So typically what you'll see is, when you have like a virtual machine and you're executing within the virtual machine, you have certain process names, certain types of devices. VMware has its own backdoor interface, so you can also test for that. There are many different techniques that the malware writers are trying to use. So it's the never-ending race between the kind of, let's say, anti-malware producers who have the sandboxes and like threat intelligence operations, like Cisco has threat grid, so they're developing all the time new methods that are trying to hide the fact that something is being run within the environment. Like one of the things you can do is your virtual machines for analysis typically have smaller hard drives, or looks to be smaller hard drives, like 50 gigabytes at most 40 gigabytes, which is not that common this time in this time in like a real machine, right? So if you detect that you have a very small hard drive, perhaps you won't be able to run it. You know, it's not a big issue for that. On the other hand, there are so many more virtual machines these days, and everybody's using them. I don't see why malware writers wouldn't be interested in infecting virtual machines as well, because they're equally important, I guess, as the real machines. I know. I hope that answers your question, but we can always go to discuss a little bit more after the break. Any more questions? No? Then we are done. Thanks very much for listening, and hope it was entertaining.